So our next speaker is Alex Montgomery from Amazon.
Hey, what's up guys, this is IK from IMK Technical Hub. Please subscribe to our channel by clicking on the red subscribe button and press the bell icon so that whenever we post a new video, you will get the notification of that video. We are new on YouTube, so we need your support, and also we will provide useful and technical videos in our channel IMK Technical Hub. So thank you and Jai Hind.
Our next speaker is Alex Montgomery from Amazon. A bit about Amazon Lumberyard, which is their game design or game engine and a design environment, and how the UX drives the design of that development forward. So please welcome Alex Montgomery.
Let's hear it for Alex Montgomery, Amazon.
Hello, my name is Alex Montgomery, and I've programmed video games for most of my life, with most of my recent work specializing in game engines. I now work on the Amazon Lumberyard game engine. We're going to be talking a lot about game engines here, so let's define our terms. Game engines are collections of tools and reusable code components that you can use to make a game. They allow you to rapidly cook up simulation or last night's fever dream using standardized parts as ingredients. These parts are adept at handling the nuts and bolts of functionality that are common to many games and are very useful for developers who do not want to code every game from scratch. Some game ingredients that engines can provide include pardon. All right. Input. So this would be your mouse and your keyboard handling, your gamepad controllers, and even your fancy new motion controls and VR headsets. How about sound? This can be as simple as background music and having some sound effects, or be as complex as 3D positional sound with velocity-based Doppler shift. Networking components allow games to communicate with game servers or other game clients, typically for online multiplayer games. But nowadays, they've expanded into communicating with web servers for statistics or social media sharing. Physics. This is a broad category that includes things like projectile computation, collision detection, and player motion. It's one of the most math-intensive areas of game programming. Graphics and animation are also particularly math-intensive and easy to mess up. This engine aspect is what makes a game look good, so it's been one of the most hotly contested battlegrounds in game engines for a very long time. Nowadays, we tend to think that developing a game starts with a game engine, but of course, video games have existed long before engines. Early games were simple and specific because they had to be programmed for a relatively slow machine and fit in a tiny chunk of memory. These were the old classics, your Pong, your Pac-Man, even later titles like Tetris. Each game was its own, programmed from scratch, with short and efficient code designed to bring that one game idea into reality. So if early games didn't use game engines, how did engines develop? The earliest projects that approximated game engines were from private companies that reused their own code. Many early sequels were built directly on the code base of their predecessors, with a few features adjusted or added, but mostly just packed with new content. Let's talk about the real Super Mario Bros. 2, initially only released in Japan, as an example. It was mostly the Super Mario Bros. Code base, with new levels and only a few code modifications to accommodate new features. This was a very common way of reducing cost and bugs via reuse of tested and shipped code. In a way, the developers had created a useful but very limited engine. You could call Super Mario Bros. 1 the Super Mario engine, and it was great at bootstrapping a new Mario game, but not useful as a general framework. Okay, so when did general purpose engines develop? Outside of sequels, some successful game companies started reusing their code in novel ways to make series or genres of games that could offer different settings and stories, but mostly rely on the same gameplay. Sierra was one of the first companies to do this well, creating a multi-part series that all relied on their typing and text-based framework that they called the Adventure Game Interpreter, or AGI. Early Sierra games, like King's Quest and Space Quest, pictured here, have used AGI. Now, while Sierra's interpreter relied on a typing interface, LucasArts created their own adventure game framework, initially used for their very popular Maniac Mansion game. They called it the Script Creation Utility for Maniac Mansion, or SCUM for short. Some consider SCUM one of the very first GUI engines since it had a point-and-click interface for building commands from verbs and in-game objects. These early engines were very successful and saved their developers time and money by reusing components, but they weren't fully fledged game engines yet because they were private and still not general purpose. So Quake was the first engine that I'd ever heard of as a young programmer, though the Doom engine did technically come before it, and it was also popular. Quake was id Software's first genuine 3D game with 3D graphics and proper three-dimensional physics. Quake's tech was such a leap forward that it changed the course of gaming. It was gorgeous, and it took a lot of clever, tight code to make it that way. Countless game designers looked at id's technology and the beautiful, albeit terrifying world that they had created and thought, what could I do if I could start with that? So the creators of Quake, as they had done with Doom, licensed their game code to other companies. Now, some took bits and pieces, some tinkered with it and adjusted it to meet their specifications, and some basically changed little more than the content and released suspiciously similar games. It didn't matter. Suddenly, a smaller game company could pay for code that they might not have the time or skill to create and craft an interesting and successful game. Quake defined the 3D engine and started a revolution. It spawned sequels and derivative engines, and there are still small tendrils of its code in modern games. In fact, all the games in this slide are built either with one of the Quake engines or their derivatives. So that brings us up to the modern era. Lumberyard is the game engine that I know and love, so I'm going to focus on it from here on out. We defined a few component categories at the beginning to be what I would consider a modern engine, so let's check those against Lumberyard. Input? Check. LY has a sophisticated system that allows you to map buttons and motions to game events, and then abstract the hardware details away. Is it important to know that the character jump command is the A button on the Xbox but the right mouse button on the PC? Sure. But once that input is mapped, the next layer of game logic needs only consider the jump event instead of the hardware that triggered it. This allows an engine to target many platforms easily, and Lumberyard can target an ever-growing number, including PC, Xbox One, PlayStation 4, iOS, and Android. Okay, how about physics? Lumberyard is flexible enough to allow you to program and tweak your own physics how you like it, but includes many complex prepackaged components like collision detection, rigid and soft body dynamics, inertia, and even rope entities. How about multiplayer? No problem. So we've got client-server, peer-to-peer, host migration, and matchmaking. It's all there. Actually, networking especially stands out in Lumberyard because of its ability to tie into Amazon's web services. Amazon provides matchmaking, dedicated servers, and large-scale storage, to name a few of their key areas. All right, how about sound? Lumberyard actually supports swappable audio backends so the developer can pick what best suits them. Typically, Lumberyard users pick a WWise variant, which is supported out of the box, offering such features as sound position and occlusion, ambient sound generators, and per-material collision sound effects. Finally, how does it look? Graphics and animation have come a long way since the Quake days, and Lumberyard is racing forward. We have advanced lighting, a programmable pipeline, and a new animation component that we'll be talking about here shortly. So that's where we are. The code is there. People can take an engine off the shelf and mix and match its components to make an amazing game. But now what? Where are we going from here? Now that technology and graphics have mostly settled and standardized, the next stage in engine evolution is user interface and user experience. Some would argue that virtual reality tech and head-mounted display graphics are the hot ticket item, but really, VR itself is just another aspect of the user interface revolution. Game engines aren't simply collections of code. They are sophisticated suites of tools that help developers turn their designs into games. If the tools are bad, it's nearly impossible to make a great game. There are different reasons why a tool could be considered poor, of course, but by far the most common tools complaint for any software is the UI. I know I'm preaching to the UX chorus here, but it can be easy to forget just how important good UI is for customers. It's not just the warm, fuzzy feeling of using an intuitive tool. Good UI saves training time, task time, and worker fatigue, and time is money. Lumberyard is rapidly evolving its tool set right now, and we are replacing and redesigning a lot of our UI. And what API have we decided to migrate towards? Qt. Qt is a great fit for us because Qt is the most mature and feature-rich GUI toolkit available. It's full-featured and flexible and has a rich community of developers. That's you. Another advantage is that Qt is primarily written in C++, which is true for most console and PC games. Games need the performance and flexibility of C++, so naturally our tools benefit from being in the same language as our games. We also provide our source code with our engine so that developers can know and perhaps tweak exactly what's under the hood. While Lumberyard handily ships on many different platforms, like many engines, the Lumberyard editor itself only runs on Windows. Now that Qt is our GUI of choice, I'm proud to say that a Mac version of the Lumberyard editor suite is nearly complete. We're hoping that having another platform to develop on will give our customers some well-deserved flexibility. I want to quickly show off a couple of our new Qt-based tools in the latest Lumberyard, starting with Emotion Effects. Emotion Effects is our new animation system, and it's primarily designed with usability in mind. It takes complex topics like blend trees and motion extraction and boils them down into an interface for artists and animators, an interface that shouldn't require extensive engineering chops. You can see our state machine editor and node-based animation editor in the screenshots. We're hoping that animators and technical artists have more freedom to implement their own ideas without having to schedule outside engineering time. So Script Canvas. Script Canvas is another new editor written with Qt, and it also uses a node-based approach, this time for logic scripting instead of animation. It is designed to marry well with emotion effects such that you can create behaviors graphically and apply them to emotion effects-made characters. It is a powerful scripting tool that can replace a lot of C++ and Lua work that was previously reserved only for software engineers. Hopefully its intuitive look and feel will empower non-programmers to dip their toe into the realm of scripting, much as QML has done for Qt users. So that's it. The first games were programmed from scratch, but they were confined by their hardware and their development time to be relatively simple. Then game engines came along and provided useful tools and components that saved game developers time and code complexity and greatly broadened the type of games that were possible to make, especially given a limited time and budget. Now that the UX focus on game engines is bringing the next revolution, we are making an engine that enables faster development with fewer specialists. We are headed towards a future where game developers can make amazing games with small teams and tight schedules, and Qt is helping us get there. Thank you.
All right, thank you.